Next on the agenda is the Open ZOS Enrollment Working Group approval. And I know this group has kind of had a few meetings and they've started to pull together their charter. And I think we have Kip and Sandy here to present that today.
Yes, thanks, John. Sandy Parisi is going to help me just discuss this, answer questions if there are any. Just let me share briefly here. I put in the notes already a couple of points about what's gone on with the project. The TAC approved this working group in December. Since then, we've held 5 meetings, I think it is. We've had perhaps somewhere close to 25 people participate. We formulated a way of approaching the working group, established the working group repo, email list, documented the results of the meetings in a charter, README document that let's go look at real briefly. Kind of the purpose of the working group, as we formulate it, is to help lower the bar for those that wish to contribute in some way to establishing ZOS environments for use in community development, for example, in open source development sort of efforts. We want to make it, it's not that the working group provides the resources, including the MIPS and any of the licensed software, but we want to make it easier for people who are willing to do that sort of thing to be able to do that without such a high cost. Going back to kind of Jerry's point about being careful of the cost involved. And one of the major costs that we see on this is the cost of system programmer support. System programmers are a scarce resource, becoming more scarce. And as you administer ZOS environments, it consumes those resources to help establish communities and those kinds of things. We've had a contribution. Matt made a very good contribution, just kind of saying, hey, if I were to lay out a simple way of thinking about what we'd love to have, similar to what you have in the Docker library sort of environment, right? A way of people going out and saying, here's what the kind of ZOS instance I would like to have, the kind of ZOS environment I'd like to have. And then the ability to request that and to make changes to it, update it, configure it in certain ways. And then the ability to start it, have it, that instance available to consume it, to stop it, delete it, whatever would come with that. We think that this is valuable because in open source, you know, it's much more about provision, experiment, enhance, and then use. And that experimentation, our lack of environments gets in the way of that sort of ability. One of the things that I've used quite often when I talk about this is to think about the Raspberry Pi model of, you know, the Raspberry Foundation said, we want people to be able to experiment on the edge of safety for a machine. And if they destroy it, they want to be able to re-image it. Well, we want people to be able to experiment on the edge of safety in certain things. As we kind of broke down all of the dimensional pieces of this, here's kind of the chart that we've ended up trying to not attack in a single file way, but have a multi-pronged approach to how we approach this. We're looking at trying to enable either environments that are emulated in some way using ZD&T perhaps, or if in some instances there are places and there are companies, colleges and such that do provide access to actual Z environments, So we want to have kind of two different work streams available to us, and we've been coached to make sure that we start with either start with a simple thing so that people who begin to use these kinds of tools don't become discouraged when it doesn't do everything they want. The simple approach suggested was that we target perhaps Unix system services as a way of that requires less sysprog intervention, and it gives people a contained environment with which to do something on ZOS. There's a possibility that people getting on to Unix system services, they don't even perceive that they're really working with the mainframe because it's so familiar to other things that they do, because it's a POSIX compliant environment. So although there's value in that, it doesn't really expand the knowledge of ZOS, but it does allow for access to ZOS resources and capabilities through Unix system services that they couldn't do otherwise, and there's value in that. A next level up of that would be being able to give people some sort of TSO access, which typically requires more sysprog support. The next level beyond that would be then starting to think about other licensed enterprise tooling that would be needed for people to accomplish the task that they want to do in their ZOS environments. And a complex space would be ultimately someone wanting to be able to develop Sysplex-enabled environments, which would require a visibility much higher to resources than a very controlled sort of environment. Within these kinds of matrix pieces, then we're thinking about how do we approach developing this. We actually have 2 leads on potentially sourcing or requesting code that could be contributed to the work group and become the basis for an actual incubation project. There was a recent blog post here about AWS partnering for IBM ZD&T environments on AWS. So right here, you're seeing the reaction to some of the needs that we felt within the open mainframe community. And this is one piece that if we actually had the ability to have this set of code that does this become something that could be reused by others in other kinds of cloud environments or other ways, if they had the appropriate licenses for ZD&T, that it would provide a basis for others to use that code. A second course on the more bare metal side is that we have a company that internally makes available to their employees. They can request some sort of a ZOS environment for this kind of experimentation, development, open source sort of work. We understand that code is written in Rex. There's been a suggestion just in the last week that we might want to think about using those perhaps as if they are contributed to the project, using those as a template, but targeting a later language, perhaps Python, as a way of developing up a set of routines that if someone has a machine and is willing to dedicate some MIPS, they would be able to download this set of code and it would help them administer the environments going forward. The work group boundaries for what it does not cover is access to MIPS or the licensed software. We're trying to make it easier to do, but we're not trying to provide them directly. And we want to, we don't feel like we have the capacity at this point to deal with the management of the donated resources. But we hope that the tooling we would provide helps companies manage those and control those donated resources. If I kind of go back to then to kind of conclude, and actually maybe I'll pause there. Sandy, do you have any comments back on any of those points as you've gone through this and helped me through kind of co-chairing this work group?
Well, I think that the intent is to try and as much as possible make it easy for companies to, like you said, donate the shared resources or resources for people to do experimentation. And there's a real pain to get people set up on ZOS, and I think this will cover some of that.
Thanks, Sandy. So our next, what we think is next in the life cycle is to continue to reach out for potential code contributions. That process of reaching out for code contributions will push us forward into other issues that we haven't really dealt with yet, which is focusing around control of loan licenses and resources. that will highlight discussions that I think will be profitable. We think we also need to recruit knowledgeable resources to define and help build the high value functions to reduce the overhead for this. Perhaps this would be expedited by more joint sponsorship with where many of these resources with capacity sit might be within the share community, and then work with some preliminary providers at some point to provide initial access experimentation to see if we're being successful at lowering the bar of administration and use.
Hey, Kip, this is Jerry. One of the things that I've been working towards for the next phase of polycephaly is actually to build a ZOS operating system. I have it in batch mode today. We worked through. What I'm trying to do is move that into polycephaly. It works. So what you would have is you would have the server pack, the base code laid down on a ZOS system, because that's what you need it somewhere anyway. Then you could have your PARM, procs, and all the other products parameters in Git, and then you could actually run the code and build a ZOS operating system from Jenkins. That is possible. I've done it before. I had it working once before in my own shop. I have parts of the code in polycephaly already, but it's not difficult. One of the key things it doesn't build, though, is the master catalog and those things, but those things can be copied and then, as a volume, and then have the res, I call it, the res volumes be built, and then you can deploy it. You can deploy any type of, any way you want to deploy it, any version of CICS, any version of DB2, any version of whatever code you want. It's just based on each different project you can select. So I have that capability started to build in my project. I just don't have it finished out yet. I haven't really had time to work on that, but that is possible.
Okay.
I mean, it is, I've done it. I've been doing manually, internally for 15 years, and it works great using indirect cataloging. So I'd be happy to help with it.
Yep. No, you can see the intersection there between what you're doing and what we're doing there. I think there's a great synergy between the two.
I like the idea. And I'd also volunteer my help for assistance programming resource, both on VM and ZOS. I've been doing both for 35 years, so.
Great.
That's great. Definitely need those.
Yes.
Questions?
So John, I think back to you.
Yeah.